Section 4.4, trigonometric functions of any angles. We're going to evaluate trigonometric functions of any angle by using reference angles to evaluate each of those functions. So the first thing is, how do we find 6 of the trig functions only knowing a point on the terminal side? So we have our initial side on the positive x-axis, and then we have the point 4 comma negative 3. So 4, 1, 2, 3, 4, negative 3. Approximately somewhere right here. So if we draw in that angle, we create a right triangle, 4 positive units for the x and negative 3 for the y. Now we know that distance is not negative 3, that's just more about where the location is. So if we figure out the hypotenuse, we can do the side squared plus side squared is equal to the hypotenuse squared, so that's 9 plus 16 is equal to c squared, so 25 is equal to c squared, so 5 is equal to the hypotenuse. So we have our right triangle. Really the only thing is now is that we have negative trig functions in terms of their value. So theta always represents the acute angle formed using the x-axis and the terminal side. So here's the x-axis, here's that terminal side to get to that point. So the acute angle is this. That represents the theta that we are going to be looking for. So the 6 trig functions, we have sine of theta, which is equal to opposite over hypotenuse, so it's negative 3/5. We have cosine of theta, adjacent over hypotenuse, which is 4/5. And then tangent of theta is opposite over adjacent, which is negative 3/4. And now we can find the reciprocals. So the reciprocal of sine is cosecant, so cosecant of theta is negative 5/3. Secant's the reciprocal of cosine, so secant of theta is equal to 5/4. And the reciprocal of tangent is cotangent, so cotangent of theta is equal to negative 4/3. And that's how you can find the 6 trig functions only knowing a single point on the terminal side. So now what we're going to look at, since we're going to be talking about different angle measures, or all angle measures at this point, what happens to the signs of the angle in a given quadrant? X is always going to represent your adjacent side, and Y will always represent your opposite side. So if you draw an angle in quadrant 1, no matter where it's located, that acute angle, theta, you're always going to have a positive X and a positive Y. And from that, Y you can see is always your opposite, and X will always represent your adjacent. This ordered pair will always be positive in quadrant 1. Every ordered pair is positive X, positive Y. So all your trig functions will be positive. Okay? So what happens when we go outside of quadrant 1? Let's go to quadrant 2. So we'll make another angle in quadrant 2. So theta is with your terminal and initial side there. And so now what? Well, now X is negative and Y is positive. So this ordered pair is negative X, positive Y. So when you look at your trig functions, which one is going to be positive? Well, if you do sine, that's opposite over hypotenuse, that'll be positive. If you do cosine, it'll be adjacent, which is negative over positive, so that'll be negative. And then tangent's opposite over adjacent, so that would also be negative. So the only one that is positive here is sine, and its reciprocal, which is cosecant. So those two will be positive in quadrant 2. What about quadrant 3? So here's theta. We got negative X, but we also have negative Y. So any angle in quadrant 3 will be negative terms of their X and Y. The hypotenuse on all of these will always be positive. So when you go and look at your trig functions, you have sine, which will be negative over positive, cosine is negative over positive, and then tangent is negative over negative. So the only one that will be positive in quadrant 3 is tangent and cotangent. The other two will be negative, and the reciprocals. Then we look at quadrant 4. So theta, we have positive x, but now we have negative y. So this ordered pair would be positive x, but negative y. So which trig function would be positive here? Well, since you have the positive x, it would be cosine, adjacent over hypotenuse. So only cosine and the reciprocal of cosine, which is secant, will have a positive value. The other ones will be negative. So paying attention to the ordered pair and the signs of them will start to help you identify your trig functions and the signs of the trig functions based on their location. So from what we just discussed, can I give you some information and you name what quadrant it's located in? So quadrant 1, x is greater than 0, y is greater than 0. In quadrant 2, x is less than 0, y is greater than 0. Quadrant 3, they are both less than 0. And quadrant 4, x is greater than 0, but y is less than 0. So remember, x and y, x is your adjacent, y is your opposite. So when you're doing your trig functions, adjacent is cosine, opposite is sine. So let's take a look here. 2a, if cosine is greater than 0, so in what quadrants is cosine greater than 0? Well, everything is positive in quadrant 1, so cosine would be greater than 0 there. Remember, cosine is your adjacent. That's your x value. So where is that going to be positive? That will also be positive in quadrant 4. Okay, because your x is going to be greater than 0, so cosine would be greater than 0 in quadrant 4. What about tangent less than 0? Well, tangent's less than 0. Tangent is your opposite over adjacent, so you need one positive and one negative. So in quadrant 2, you have one positive and one negative, so it could be there. And also in quadrant 4, you have one positive and one negative. So where do they overlap? Where is cosine greater than 0 and tangent of theta less than 0? That would be in quadrant 4. Alright, let's take a look at the next one. We have cotangent is greater than 0. So once again, cotangent is the reciprocal of tangent, which is opposite over adjacent, so adjacent over opposite. But if it's greater than 0, they both need to be greater than 0. So that happens in quadrant 1. So we got quadrant 1. Now, they're both negative in quadrant 3, but a negative divided by a negative is a positive. So quadrant 1 and 3 is where cotangent would be greater than 0. Secant is the reciprocal of cosine. So same ratios, just reciprocal. So that doesn't really affect the sign. You got less than 0. So where is cosine less than 0? Cosine's your adjacent. So cosine less than 0, that's your negative x. So adjacent, so less than 0 for x would be in quadrant 2, and also less than 0 in quadrant 3. So where do they overlap? Quadrant 3. So quadrant 3 is where cotangent would be greater than 0 and secant is less than 0. So this example might look familiar. I've given you one of the trig functions and asked you to find the remaining 5, but now that we know these angles can be in different quadrants, adds a little bit more to it. So knowing that we have cosine of theta is negative 2/3, cosine is adjacent over hypotenuse, but one of them has to be negative. Well, the hypotenuse will always be your positive, so we know it's going to go negative 2 to the right on the x-axis. Cosine is adjacent over hypotenuse, but it could be in quadrant 2 or 3. Well, how do we know that? Well, that next piece of information says that theta is greater than pi over 2 and less than pi. So that tells us it must be in quadrant 2. And so negative 2, knowing that theta is the acute angle with the x-axis and the terminal side, negative 2 is the adjacent side, and 3 is the hypotenuse. So now you can go ahead and do the same thing that we've done on all the other ones from earlier. Negative 2 squared plus, we'll call it y squared is equal to the hypotenuse squared. So that's 4 and then 9, so subtract, that's 5. Y is equal to the square root of 5, and that's positive square roots of 5 because you're going up in quadrant 2. So now at this point you can find the remaining 5 trig functions based on that triangle. So sine of theta is opposite, so that's square root of 5 over hypotenuse. Cosine of theta is adjacent over hypotenuse, that was given to you. And then tangent is opposite over adjacent, so that's negative square root of 5 over 2. And then you can do the reciprocal of each of these as well. So cosecant of theta is 3 over the square root of 5, which, if you rationalize the denominator, which would be 3 square roots of 5 over 5. Cosecant's reciprocal is secant of theta. So secant would be negative 3 halves. And then cotangent is the reciprocal of tangent. That would be negative 2 over the square root of 5, which once you rationalize that, that would be negative 2 square roots of 5 over 5. So same similar problem from before, but now we're worried about location also, so we can get the signs correct. And then look at this. So from what we talked about a little bit ago, where are your positive angles? Sine of theta is positive, cosecant is positive. The other 4 are all negative. So 2 trig functions from quadrants 2, 3, and 4 will be positive, and the rest will be negative based on their location. And for the last example here, same idea. Tangent of theta is negative 4, so that's negative 4 over 1, opposite over adjacent. But where is it located? Well, tangent's negative, so where is tangent going to be negative? Where you have one positive and one negative. So that could be either here or here, where sine and cosine are x and y. There's one positive, one negative. And then where is sine less than 0? So sine, remember, is your opposite, which is your y value. So where is that negative? Well, that could be either here or here. So it looks like we're going to be in quadrant 4. Tangent, here's theta, so tangent is opposite, so that would be negative 4 over adjacent, which is 1. So negative 4 over 1, and that fits that sine of theta would also be less than 0, opposite over hypotenuse. So now that we have that information, we can figure out the rest of the triangle. So 1 squared plus negative 4 squared, that would be 17, is equal to r squared, so r is equal to the square root of 17. And now that you have all 3 sides, once again, you can find the remaining trig functions. So sine of theta, opposite over hypotenuse. And then we will rationalize, so that's negative 4 square root of 17 over 17. Cosine of theta is 1 adjacent over hypotenuse. Once again, rationalize, square root of 17 over 17. Tangent of theta would be opposite over adjacent, which is negative 4, that was given. And then we can also find the reciprocal functions as well. So cosecant would be the reciprocal of sine, so that's square root of 17 over 4, and that would still stay negative. Secant would be the square root of 17 over 1, or square root of 17, and then the reciprocal of negative 4 is negative 1/4. And so since we're in quadrant 4, you can see that cosine would be our trig function, and secant, that would be positive, and the other 4 would be negative. So that ends the section 4.4 notes, all about really about location, looking at the 6 trig functions based on location, and start paying attention to those signs of what the trig functions are based on what quadrant you're located in.